just going to cover a couple different definitions of acids and bases. So first we're going to go over the Bronsted-Lowry definitions of an acid and a base. And so they define an acid as a proton donor, proton just being H+, and then a base is likewise, it can just be the opposite, which will be a proton acceptor. And so if we look at an example, we can take hydrochloric acid and sodium bicarbonate. And so this is going to give us carbonic acid and a salt, an NaCl. So this is a salt. And so if we look at this, we can see that the HCl that we started with lost a proton. So it's a proton donor, so this would be an acid. And then we see the sodium bicarbonate turns into carbonic acid, and we see we have we gained a hydrogen, so we added an H+, so that means it's a proton acceptor, which would make sodium bicarbonate our base. And next, if we look at the Arrhenius definitions, first off, an acid, he defined it as something that produces H+ ions in aqueous solutions. And so this is actually really similar to our Bronsted-Lowry definition, which was a proton donor. And here we're just saying that it produces the protons. So they're basically saying the same thing. So that's not too hard. An example, we can use HCl again. And if we look at this and see how this actually plays out, we have our HCl. If we put it in water, make it an aqueous solution, we're going to get H+ and Cl-. So we can see that it produces the H+ ions, so it is therefore an acid. Then if we look at a base, they defined a base as something that produces hydroxide ions in aqueous solutions. And so this is a little bit different than our Bronsted-Lowry definition, because we didn't talk anything about hydroxide ions in the Bronsted-Lowry. And so if we look back up to our example from above, we said sodium bicarbonate was a base. But if we look at our equation, that base never produced any hydroxide ions. So while it's considered a base for Bronsted-Lowry, it's not considered a base under the Arrhenius definition. But if we look at an example of what would be, we can say sodium hydroxide is, because when we put it in an aqueous solution, we get Na+, we get OH-. So we see that we produce that hydroxide ion. So these are two different types of definitions for acids and bases.